Hi, and welcome to another video. Today, let's have a look into modifiers. More specifically, just into the padding modifier for the beginning. I have created a new page here in my test application, where we will be playing with the modifiers a little more in the future. Right now, I have a single box over here with a text inside, and this box gets some modifier padding, which is of 8 pixels. Now, modifiers can be placed in many different places, so we can have a padding modifier defined also over here. Let's save that. Let's rebuild the app. And you can see we have more of a padding over here around the text, because now we have both on the box and both on the text a modifier that is setting a padding. Moreover, we can have many padding modifiers chained. So let's say we have one for 8 and one for 16 dp. Let's make the code nicer. Let's run it. And here we go. We get two combined paddings right now. Let's modify this padding to be something crazy. Let's save that. Let's rerun it. There we go. Now let's remove this extra padding. We don't need it for anything right now. This is helpful if you are chaining different modifiers. So if you would be chaining a padding with some borders, then you can add one border after one padding after one border, and then have a couple of different borders separated with different paddings, or offset in a way with a padding from where the border starts. However, that's for another video. Today, let's have a look inside of what the padding is. And first of all, you can see that this version of modifier.padding extension function allows us to set all paddings with the same value. So we have this all over here, which gets some dp, and then we assign it to all of the padding, all of the sides of the padding, so start, top, end, and bottom. There are of course different versions of that. So here we have a padding that takes horizontal and vertical values. Here is a padding where you can assign each value separately. And finally, we also have a version over here which takes padding values as the input. And padding values can have different values inside of it. So it's just another wrapper for the specific values of a padding. It doesn't matter which one will you be using of this extension methods, they all are using under the hood this padding modifier over here, except of the one with the padding values, which is slightly different. But let's have a look at this padding modifier class. It gets a couple of arguments, so we have all the paddings for start, top, end, and bottom. We have also this right to left AWL, but this is something for another video. This padding modifier is actually a layout modifier, and if we have a look over here, then a modifier.element that changes how its wrapped content is measured and laid out. So padding modifier wants to add padding around an element. Here we have a text, for example. We want to add padding to this text, which means we need to remeasure it and we need to lay out it differently with the padding around it. And thus, this is exactly what this layout modifier is for. So padding modifier is extending this layout modifier. In the init block, we have a require over here, and require is doing a very simple thing. So you give it a boolean value, and in case this boolean value is false, you can see here, then we are throwing an illegal exception, illegal argument exception. Ping back to here, so we ensure that each of the values of padding, so start, top, end, and bottom, are basically non-negative, but it also can be unspecified. Then we have this measure method overridden over here. If you remember from the documentation of the layout modifier, it said that we are changing how the content is measured over here and laid out. So for that, we need to override this measure scope.measure extension function. And this takes two arguments. It has this measurable over here and constraints. So a measurable, what is a measurable? Measurable is a part of composition that can be measured, and this represents a layout. So at this point, we are getting some kind of an object that is not yet measured, but it is measurable, it can be measured. And it comes with this method over here, measure, which actually can be used to measure the measurable. The result of measuring over here is something called a placeable. So if we have a look, a measurable, let's say, is an interface, and it has this one function over here which gets constraints, and based on these constraints, it returns an already measured placeable. And then if we have a look at the documentation of placeable over here, a placeable corresponds to a child layout that can be positioned by its parent. So at this point, an element is measured and it is ready to be placed on the screen somewhere on the layout by its parent. So it comes with the rule, similarly like in Flutter, that constraints go down and sizes go up. Now being back over here, if you have a look what happens. So let's start from top. We have this horizontal and vertical, and this horizontal and vertical are just combined paddings for horizontal and vertical axis. So for horizontal we have start plus end, and for vertical we have top plus bottom. And we are measuring this measurable by giving it current constraints, but offsetting them by the padding, the horizontal and vertical paddings. So in other words, this constraint over here, for example, came with a box 100, 100, and then each of these values, let's say, is 5. So we have horizontal and vertical 10, 10. So here we are offsetting negative horizontal and vertical. So finally the constraint over here will be 90 per 90 and not 100 per 100 as here, as what came to this measure method that we are overriding. So the final element, the placeable element, this will be of a maximum size of, for example, later a 90 and 90, plus of course the padding that we are adding ourselves. So finally we are defining the width and height of our layout. So here we have a layout. And this again, we have a constraints that came to this function over here. And we are constraining width and height by giving it the placeable width plus the padding right now. So this is without the padding, and this is with the padding over here. So in our example here would be 90, and this will be 100. And if you just have a look what constraint width does, there's not much with it. It just takes the current width that is provided over here, and we call the coerce in. So this value must be returned within a range of min width and max width. So if it's smaller than min width, it will return the min width. If it's bigger than max width, then the max width will be returned. For more details on coerce in and coerce at least, for example, here and at most, have a look at my previous video where I briefly covered these methods. Finally, we have this layout that we are returning over here. So it's just a function and it's returning a measure result. So first we had our measurable, we measured it, it returned a placeable, and out of this placeable we also can return this measurable result over here. And the result is coming actually from calling something on placeable. So on placeable we call, depending on this right to left hour value, either relatively placing the element or just placing it. And then if we have a look at the place, for example, place is a placeable at x and y in the parent's coordinates system. Let's say that around this text we have some box, and this box has some coordinates of x and y, and we will place the text within these coordinates. So it will not be like a global coordinates, but coordinates of the parent. And that's it. That's everything that is there in order to measure and lay out the element, our composable, with a padding. That's the whole implementation of padding modifier. Of course, down here we have also the hash code and equals methods, which very much could have been generated over here. This was a very brief introduction to first modifier and how it's implemented. And based on that knowledge, in some of the future videos, we also will look how to possibly, maybe, create our own modifier. But for now, bye bye.